Alright, so today we'll be going over combustion, what that is, how it relates to wildfires. So, start off with an essential question. Why the heck is California burning down with all these wildfires? Why have they become so much more destructive in these last few years? If we look, we can see that the acres burned have increased steadily. We can see that the spring and summer temperatures have increased steadily as well. And then we can see the forest acres burned and the spring summer temperatures burned. The hotter it is, the more it burns. The correlation is temperature and wildfires. That means it's probably global warming and a whole host of other problems. But really, I think that's global warming. So, what problems do these increases in wildfires cause? Well, most notably for us, it kills people. It destroys homes and roads and towns. And over here, and it let people connect with each other. But it's not all bad, right? Wildfires, and fires in general, are one of the key aspects of restarting forests. It's one of the cycles that is used by life itself to restart. It clears away dead trees, and opens up acorns, that then sprout into new trees on the corpses of their fallen grandfathers. So, now we gotta ask, because we know we're getting more wildfires, we know what they do. We have to ask, what is a wildfire? What is combustion? Well, it's all based around the fire pyramid, right? You have oxygen, fuel, and heat that starts it, and then the oxygen and the fuel will feed back off each other, then heat it, and they will cause heat, which will then cause another reaction. So, what is this reaction? What does that mean? So, we know that O2 and the fuel are reacting with each other. So in this case, I chose methanol, because I thought it'd be easy to demonstrate. And the heat is what breaks the bonds and lets the reaction occur. It gives the activation energy required. So, what does this look like in actual chemistry? Well, it starts out with methanol and 3 pieces of oxygen, which will then go into 2 pieces of carbon dioxide and 3 pieces of water. And we can see right here, I display it graphically. We have our methanol, we have our 3 things of oxygen, and the world isn't all in these like nice little boxes. So, like that with entropy, and I placed them kind of roughly around, but I also did that to be easier to show where the bonds can connect. So if we go from here, the heat is added, the bonds change into the ones that will create oxygen, that's our water, carbon dioxide, a whole bunch of that, and if we sort this, get 2 carbon dioxides and 3 waters, but it does line up with the previous equation. You can see the combustion is the movement of oxygen. A reaction that involves oxygen that is exothermic. So, how do we measure how powerful, how the energy is released? Oh, we've learned this equation, Q is equal to mass delta T times heat capacity, and delta T is change in temperature. Q is energy released in joules, and mass, grams. So, start up a quick example problem. We have 2 sticks that are cut from different trees, and your job is to figure out which is more dangerous than fire, aka which releases more energy per gram, so answer in joules per gram. So we have stick of tree 1, which is 50 grams that we're burning, we have stick of tree 2, it's 80 grams that we're burning. So if we burn both of them, 500 grams of water, collect the energy burnt out of them, we see that for stick 1, it raises the temperature by 12 degrees, and for stick 2, it raises the temperature by 19 degrees. So then we apply problem. Q1 is stick 1. So we cross out the matching units when plugging the variables. We end up with Q1 is equal to 25,080 joules. And if we divide that by the number of grams, we find out that it's 501 joules per gram for branch 1, which means that tree 1 will burn at 501 joules per gram. Q2 in a heat process, but a little more condensed. And I see that's 496. What's important is because stick 2 burned to a higher degree, but it was also bigger. You gotta watch out for that kind of stuff. And this means, therefore, branch 1 is more dangerous in the case of a 4-fire because it releases more energy. So, how do we see what is up? How do we see what is going on in our wildfire? And how do we see what we can do to prevent it? Well, we can qualitatively see the values of these trees, right? We can see if it is tree 1 or if it is tree 2. And we can see that this one has a darker leaf and this one has a brighter leaf. We can see this one's skinnier and this one's wider. Qualitative is the qualities of the tree, while quantitative is a value. So here we have 50 trees, or we know that there is 2 leaves per twig on the tree. They're going to be direct values, something that could be displayed by a number rather than by words. So we can see, if we go back up to the beginning, that quantitatively, the number of wildfires has been increasing for many, many years. And we can see that the temperature is correlated with burning amount. We can see that the heat of the year is pretty much proportional to the amount burned. Now those are all the quantitative things that we can see. Qualitative stuff is we can notice that there is more smoke that is being displayed in our atmosphere. It's becoming hazardous and visible everywhere, right? You can see that, for instance, the sky is turned fiery, vibrant orange on several occasions. All these qualitative and quantitative things aren't just applicable to science, but are actually key to determining what is going on in our lives.